everyone. So today we're going to talk about time-activated relays. Let's say you want to turn on a relay at a particular time and or date. That's what this video is all about. We have an 8-channel relay controller with our Particle Photon module installed, and it is connected to the Particle Cloud. If you have questions on how to set up your Particle module, associate it with your account, and connect it to the Particle Cloud, you can head over to docs.particle.io. They have some really nice information there about associating your Particle module with their cloud. They also have a reference where you can check out some information on programming the module. If you go here and then you go under firmware, you can see all that information. Today we're going to be using the time library. So if you go here under libraries and then you go down to time, it talks about the time library. The time library allows us to get the current date and time. Every time the Particle module connects to the Particle Cloud, it will get the new current time and set the module to that. It has a real-time clock built in, so if it loses connection to the cloud, it will still have the current date and time, but just every time it connects, it resyncs its time with that server. So we're going to use this to get our date and time. And then based on that date and time, we're going to execute events. So we need to load some events into the controller that will execute at a particular date and or time and execute a command for controlling the relays. So we have a really nice example application for that. If you head over to build.particle.io/build and then click on the libraries icon here on the left, and then you click in under Community Libraries and search for NCD8 Relay. It should show up here. You'll click to select it. This will load that library, and we have a few examples here. We've got Cloud Control, which basically allows you to execute functions from the Particle Cloud, Loop Test, and Time Activated Relay, which is going to be the one we use today. This time-activated relay example will allow us to store events into the controller and execute them based on the current date and or time. What this library does is it essentially listens for an event to be published to the Particle Cloud with new events. So let's talk about this library a little bit. Here we have some variable declarations. These are really just for reference. The library doesn't use this at all. It just lets us know the time zones. So Central Time is -6, Eastern's -5, Mountain's -7, Pacific's -8. These are all just US time zones. If you're not in the US, you can look up your time zone and then use that. The next variable we have here is a multi-dimensional array that stores our events. We have 28 indexes, and each of those indexes contains 9 integers. Those 9 integers contain the events year, month, day of month, weekday, hour, minute, second, and 2 bytes for the command we want to execute. You'll see that we only have 28 of these. The reason for that is the event that we can publish to the Particle Cloud allows us to publish up to 255 bytes. If you take 255 and you divide that by 9, you'll see that we can only have up to 28 possible events stored in EEPROM. Or, I'm sorry, we can only have 28 events come through that event publish. Number of events is a local variable we use to see how many events we actually have stored in the controller. Bool process is a boolean to let us know whether or not we should evaluate the current date and time. These are the function declarations. This one here will fire whenever we publish our event with our new event lists. Set zone is going to allow us to set the time zone of the controller. Clear memory is going to clear all events, basically clears all EEPROM out of the controller. And serial print memory is just a debug function that will print all EEPROM to your serial console. We're importing the NCD8 relay library here, and we're declaring a local instance of it called controller here. And then let's get on to setup. In setup, we're going to set the address of the controller which initializes it. We're passing it 000. This is the status of the 3 onboard address pins, which you can see right here. We've got A0, A1, and A2. I don't have any of the jumpers installed, so I leave these all to zeros. If you installed A0, you would set the first one here to 1. Particle subscribe is subscribing to an event called time event device 1, and then it's calling the function new events handler, which we declared up here. And we're using my devices because that is going to be a private event. So it's important that you have my devices set here. That lets it know that this is a private event that you're looking for. So we're going to subscribe to the event, and then we're going to publish those functions for setting the zone, clearing the memory, and printing the memory. We're going to read the stored time zone out of the controller on boot up. So whenever we set the time zone, we're going to set a byte in EEPROM at location 0. So we read that out, and then we say if it's not 255, because the default value of all EEPROM is 255, so if it's not 255, then we must have something stored there. So then we're going to set that time zone variable to that and multiply it by -1. The reason we do this is we can only store a value from 0 to 255. We can't store negative numbers. And as you can see, the zone needs to be a negative number for US zones anyway. Other time zones around the world are going to be positive, so be sure and check that if you're not in the US. Then we're going to set the zone on the time library that we use to read the current time. So we'll set that zone to the zone variable. We'll set that process boolean to true, and then we're going to execute the function read stored events. So we'll head down here to read stored events. Read stored events is basically going to cycle through EEPROM and get all of your stored events out of EEPROM. Then it's going to populate them to that multi-dimensional array that stores the events so that we can check them in our cycles. So that's all this function does. I'm not going to delve into it too deep. All the source code is here. If you want to take a look at it, you're absolutely more than welcome to do so. So back up here in the main loop, after we get done with all that, we're going to go in the main loop and we're going to say if process, then eval time, and pass it all of the current time values like year, month, day of month, week, day, hour, minute, and second. We're going to process that once per second. We're processing it once per second because we don't want to evaluate the same event more than once because it'll execute again. And then, of course, if process isn't set, then we're just going to print to the console no stored events every 2 seconds. New event handler is going to handle that new published event that we're going to send out with our new timed events. And essentially all that does is prints to the console to let you know that, hey, looks like we've got some new events, and that calls another function. You could execute some other stuff here if you wanted to. So that's going to call the store events function. The store event functions is going to basically take that that new event, which is going to be a comma delimited string, and it breaks that comma delimited string into integers and then stores them into EEPROM. That's all that this does. It just takes the new event, stores it into EEPROM. We do not populate the multi-dimensional array here. Instead, we call read stored events. Read stored events we already covered basically reads all the events out of EEPROM and then populates them into that multi-dimensional array. So there's no point in doing that twice. So we just call that and execute that. Let's go over the other functions here real quick. Set time zone or set zone is that particle function that we declared. That's basically going to let us set the time zone, and that's all that this is doing here. Split string to int array, that takes that comma delimited string that's the event or is the list of events we want to store. This is just a helper function that takes that string and splits it into integers, basically a big integer array. Clear memory is going to clear all stored events. Basically, it clears all EEPROM. Cycles through all 248 locations in the EEPROM and writes 255 to them, which is the default value. So that will clear everything. Serial print memory is just that debug function that prints all EEPROM to the serial console. So let's go back up here and let's take a look at eval time. This runs in the loop and executes once per second. You pass it the year, month, day of week, hour, minute, and second. So inside here, we're going to cycle through every single stored event, which is in that multi-dimensional array. And so we're doing a for loop, and we're just going through the number of events. So inside this for loop, we set a boolean called run command, and we set it to true to start with. Then we evaluate all of the year, month, day of week, hour, minute, and second variables. So we're taking the current time, like year, and we're comparing that against the event stored in our multi-dimensional array. Here we're looking at event array at index I from our for loop, and we're looking at byte 0, or integer 0, which is going to be the index of our year. So we're going to say if the current year does not match the event year, then we're going to hit another if statement here, and we're going to say if the stored year does not equal 0, then we're going to set run command to false. That means we don't want to execute this event. We can set the year to 0 if we don't want to compare against it. If we set it to 0, it's just going to basically ignore the year, and that's why we do that. We do the same thing for month. We're going to look at our stored month, compare that to the current month, and then we're going to say, well, if that doesn't match and it's also not 0, then we want to set run command to false. The valid range for month is 1 through 12. We're going to do the same thing for day of month. Valid range of day of month is 1 through 31, so if it's 0, we're not going to worry about it. Day of week valid range is 1 through 7. If it's 0, then we're not going to worry about the current day of week. Hour valid range is 0 through 23, so if it's 24, then we're not going to worry about it. Minute valid range is 0 through 59, so if it's 60, we're going to ignore the current minute. And second valid range is 0 through 59, and if it's 60, then we won't worry about it. I do highly recommend that you always set the second variable, because if you don't, then this is going to process every second as long as all the other variables match. So if you're using like the toggle relay function, it's going to toggle the relay every second if you don't set the second variable in your event. So if we get through all of these and run command, which was set to true, is still true by the time we process through all of those, then we're going to print to the console and let you know that we're running a command, and then we're going to call the function execute command. And we're going to pass it integers 7 and 8 from our stored event array. Those are the 7th byte, or the 7th integer in that array is basically our command ID, and the 8th is optional event data. So let's go look at this execute command function. As I said, execute command function takes two integers, a command ID and a command data. A lot of times we don't use command data, but we always use command ID. So in here we're going to hit a switch case statement. We're going to say if command ID is 0, then that means turn on all relays. If it's 1, then turn off all relays. If it's 2, then we're going to set the status of all relays and pass command data as the status we want to set them to. That can be a variable from 0 to 255. 0 would be all relays off, 255 would be all relays on. 1 would be just turn on relay 1, all others off. If you passed it 3, that would turn on relays 1 and 2 and all others off, so on and so forth. Every relay on the board has a integer, or has a bit value in this byte. And then we have controller.turnOnRelay. If the case is, if the command ID is 3, we're going to turn on a particular relay. We're going to pass it the relay number we want to turn on, which is going to be 1 through 8. Same thing for turn off relay. We're going to pass it a relay 1 through 8 for the particular relay we want to turn off. And toggle relay, same thing. We're going to pass it a relay number 1 through 8, and that's going to toggle the current status of that relay. That's about all that there is to it. So let's go ahead and flash this firmware in. So we want to make sure that this time-activated relay to INO is selected, and then we're going to click on Use This Example. After we click that, we want to make sure that our current controller is online and is selected. If you have more than one device, you're going to want to click a little star over here that will allow you to select that particular device. I only have one controller on this account, so it's selected by default, and I can see it is online because I have a glowing cyan indicator here. So we have that forked and we're ready to flash it. So you'll see the magenta LED on the board flash, and then after it's done flashing, it's going to reassociate with the Wi-Fi indicated by a green flashing LED. Then it's going to reconnect to the particle cloud, and you'll know it's connected whenever you have a breathing cyan LED there. So the controller's running our firmware and it's ready to go, but it's not doing anything yet because we don't have the time zone set and we don't have any events stored in it. So to do all that, we're going to head over to mobicle.io. Mobicle.io is going to allow us to publish our event and to call the function on the controller to set the time zone. So let's set the time zone first. To do that, we'll just click on our device, which is right here, and then we're going to click on Set Time Zone. I'm going to pass it a 6. My time zone is actually -6, but my function in there takes care of that by multiplying this by -1. So after we're done with that, we'll click the Send button. That's going to set the time zone in our controller. So now that our time zone is set, we can actually store an event into the controller. So we'll go back to the device list, and here under Event Publishers, you'll click the plus button to add a new event. After you click the plus button, you'll be prompted to enter the information for the event. I already have one entered here. It's called Toggle Relay Every Minute. The event name is Time Event Device 1. That is set in firmware here where we subscribe to the event. Of course, you can rename this to anything that you want. That's just what I happen to have mine set to. And then we want to pass it the data for that event. You can see I already have that all entered here. The first 0 indicates to ignore the current year. The next one means to ignore the current month. Then we're going to ignore the current day of the month. We're going to ignore the week. We're going to set the hour to 24 to ignore it because its valid range is 0 through 23. We're going to ignore the current minute by passing it 60 because the valid range there is 0 through 59. And then we're going to tell it to execute on second 0. So the first second of every minute, this is going to execute. Then we're going to pass it the command ID we want to execute, 5, which is the toggle relay. We can see that down here. Case 5 is toggle relay. And then we're going to tell it the optional data is 1, which means toggle relay 1. We're going to enter 60 for our time to live for this event, which means the controller has up to 60 seconds to check in with the particle cloud and get this event. So once you're all done with that, you can click Submit, and that actually added another one there. And we'll just click on this to store those events into the controller. So we'll click, and then we just need to wait for the relay to toggle. And you'll see there the relay toggled. It's going to do that every minute because we have our minute set to ignore and our second set to 0. So every time the current second equals 0, this command is going to execute. Now, of course, you could set this up to, let's say we're going to turn on relay 3 on Christmas. So we'll call this command turn on Christmas lights. The event name is going to be what we set it to what we set it to evaluate to, the particle, the event name. So we'll copy that, we'll paste that in here. Time event data, okay, so it's 2016. So I want to say that the date is 2016. The month is going to be 12. The day of month is going to be 25. And for the hour, let's say we want to do this, you know, just as it's getting dark on Christmas. So that's what, about 6 p.m.? 6. So the hour will be, well, the hour will actually be, this is in 24-hour time, so it's actually going to be 18, I think. We'll set the minute to 0 and the second to 0. The command ID is going to be 3, which is, I think that's right. Let's go back and check. Yep, 3 is to turn on the relay. And then the relay number we want to turn on is going to be relay 3. So that's one event. Now, what if we want to put another event here to turn it off the following morning? Well, what we would do is we would just enter a comma and start entering that. So we would enter 2016. This is going to be on the 12th month. Is going to be on the 26th day. And we'll turn it off, you know, in the morning, like let's say 8 a.m. The minute's going to be 0 seconds, 0. We're going to turn off the relay, which is command ID 4, and the relay number of 3. And we can do up to 28 events in here like this. You might want to open up a text editor and actually write all this out so it's a little bit easier to read and then paste it in here. But that's essentially all that you would do. So we'll type that and we'll click submit, and then we have a button here to store those events. So that's pretty much all that there is to this. Like I said, we're using an 8-channel relay controller here. This one happens to have 10 amp relays on it. We have several other 8-channel relay configurations. If you head over to ControlEverything.com, click on Particle Photon, and then here you'll sort by number of relays and set that to 8. We've got several other versions. We've got a 20 amp version here. We've got a 5 amp DP-DT. We've got a real small 1 amp 8-channel controller. We've got solid state relays that use really nice Cry-DOM solid state relays. And we've even got a 30 amp controller here. And this is the one we're using here, is the 10 amp. So hopefully this all makes sense to you guys. If you have any questions, be sure and let us know. You're more than welcome to check out the full source for the NCD8 relay on our GitHub repository. You can click on firmware and you can see this is the library. You click on examples. Here's the cloud test, loop test, and the time activated relay. That's all right here for your viewing pleasure. So if anyone has any questions, be sure and let us know. And hope you guys have fun with this. This could definitely be ported to the 1-channel, 2-channel, 4-channel, the 16-channel, the 24-channel, the 32-channel relay boards. I just happened to do it for the 8-channel board. This could absolutely be ported to other numbers of relays. So I hope you guys have fun playing with this, and if you have any questions, just let us know. Thank you.